So in the previous page there, or video, we also took a look at a way of graphing out a linear function based on a series of points. It's a pattern, an equation, whatever we want to take a look at. Now we're going to take a look at how can we graph a linear function using an equation. So the final way to describe a linear function is using an equation, okay, to compare the values. Okay, so an equation will always have an x and a y value, and there'll be some sort of comparison. You can see a little bit of how that works, and we're going to dive into this even deeper throughout the course of this unit. As the equation needs to be suitable for all possible points in the function, the two sides of the table of values will be represented by variables. Okay, so if we think back to those tables that we took a look at in previous ones, they had an x and a y component, or a left and a right component. Those representing the variables, okay, and we're comparing the two. Each value of x gives a certain value of y. So again, often x and y are used, but any letter, as we saw with our last example about hourly wage, can be substituted or used. Okay. An equation consisting of variables is used to compare the two values, and if one is known, the other can be calculated through the equation. Now again, it's comparing the two values, but it's also showing the relationship between the two. Once we graph it out, it's demonstrating the relationship or the pattern in a visual sense that is on the graph. Is it going up, down, sideways, straight up and down? What is the relationship that we have? So let's explain how these two variables are going to be related. So we have a couple equations here. We have x plus y equals 6. That means that the two variables, that's supposed to be the two variables have a sum of 6. They add up to 6. For the second one here, the difference means subtraction, between two numbers is 4. Okay, so the difference between two numbers is 4. Again, the first number has to be bigger than the second number, because if it's the opposite, then it would be -4. But the difference between the two numbers is 4. And the last one here, we have 2 times a number, which is x, plus 3 is the answer, which is y. Okay, so if we multiply the number by 2 and then we add 3, that's going to give us our answer. This is something that we're going to get very familiar with a little bit later on in our lesson, or sorry, in our unit. Let's create a table of values for each of these equations. So the first one here, we have x plus y is equal to 6, and now the toughest part is, where do we start? What is our first ones? Well, let's take the x values 1, 2, 3, 4, 5. Okay. If x is 1, what number do we need to add to get 6? Well, it'll be 5. When x is 2, we need to add 4. When x is 3, we need to add 3, and then 2, and then 1. Here's a linear function, a pattern. As x goes up by 1, y goes down by 1, because the two have to add up to 6. So that's one that we can do. The next one, x minus y is equal to 4. Well, let's use the same ones again. 1, 2, 3, 4, 5. Okay? 1 minus what gives us 4? Well, it's -3, -2, -1, 0, 1. Okay? These ones, as x goes up by 1, y goes up by 1, because the difference has to always be 4. Okay? So it's a difference in between the two numbers. And the last one maybe could be considered the trickiest of them all at this point. Y is equal to 2x plus 3. Again, I'm going to use the same ones. 1, 2, 3, 4, 5. If x is 1, we have to now plug it into the equation to solve. 2 times 1 is 2, plus 3 is 5. 2 times 2 is 4, plus 3 is 7. 2 times 3 is 6, plus 3 is 9. And you'll notice we're going up by 2 every time, so we can continue the pattern with that one there. All right, so that is there's our patterns. How do we graph it out? Well, I'm just going to graph out the first one there. We don't need to do anything more. Because this one does continue on, I'm going to just bring my graph in a little bit here. Again, where we put the axes doesn't really matter as long as it's labeled. I need to go up to 5. So I'm going to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I will always fully label all the way to each side. I don't label 0 though. And our points, we have 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. And there are other points that work as well. If we took a look along the rest of this line here, and I'm just going to draw it out. Okay, every point along there is going to work. Okay, these ones that were given here, okay, 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1 all work, but 6, 0 will work, 0, 6 will work. If we have 0.5 and 5.5, that works. Okay, there's an infinite number of values that work in this case here. Sorry, that was off the screen there for a bit. Infinite number of values that are going to work for this case. Okay, there's everything in between, everything past. That arrow represents that we could even move into the negatives on either side and it would still work. Okay, we could find two numbers that add up to 6. There's an infinite number of possibilities, but this demonstrates how that relationship is happening. This is the last lesson of, or last video of this lesson, and the assignment that, if you're in my class, you're going to be working on is LI.01, numbers 1 to 10. And so you can work on that now, or maybe you have already gotten started based on the other videos that you've watched.